All right, so by popular demand, let's do some trig. All right, so if we look at this first question, this is a past paper as well. Question 5 in this paper. Typical way that they could ask questions in the trigonometry section of the exam. Paper 2. All right, so if that cos 2 theta equals minus 5/6, where the same angle 2 theta is between 180 and 270, calculate without a calculator these expressions. All right, so they are giving you information about the ratio. Cos is adjacent over hypotenuse, and they're telling you where you're working. So the first thing you have to do is say, where is cos negative, which is in those two quadrants, and then where is that same angle between 180 and 270. So you are actually working in the third quadrant. That is where you will draw your triangle with a 90-degree, a perpendicular onto the x-axis. Okay. Your reference angle is there, but the actual angle is there. Right, so the cos of 2 theta is 5/6. So the adjacent to this is 5, right? And it will be minus 5 because it's on the negative x-axis. And the hypotenuse is 6, and the hypotenuse is always positive. Hypotenuse is opposite the 90, right? And so your point is here to always work out the missing side. So in this case, the y value. And you do that by using Pythagoras. Pythagoras says the square on the hypotenuse equals the sum of the squares on the other two sides. So 36, that is 25. So if you take it over, it's minus 25. And that is 11, right? So if you square root both sides, it's plus or minus root 11. And because this is parallel to the negative part of the y-axis, this will be negative root 11. So you now have all your sides in that right-angled triangle, which means that you can find the sine of the same angle 2 theta. It's the same angle as you produced a triangle for. So sine is opposite over hypotenuse, minus root 11/6. So the 4 marks comes in here, and then your final answer will be 1 mark. So 3 marks for this, and 1 mark for the final answer. This, however, is not the angle that you used for the triangle, right? So it has a sine squared. If it's a sine squared or cos squared, you're thinking of the double angle formula for cos. So in other words, cos of 2 theta, for example, is 1 minus 2 sine squared theta. So there is the sine squared theta. We're going to make it the subject. Okay, so if we rearrange this, so what I've done is I've taken that over, and then I'm going to throw the cos 2 theta over. Right, so now 1 minus, and the cos of the angle, that same thing was this answer, minus 5/6, which becomes 1 plus 5/6, which is 11/6. All right, so that's your sine squared theta, and then that is 2 sine squared theta. We now need to divide it by 2. So sine squared theta will be 11/12. Right.
Ma'am, I have a question.
Mm-hmm.
I wanted to ask you, for the first one, where you put minus root 11/6, do you have to put the root sign? Or does the root sign go away?
This side is root 11.
Oh, okay, ma'am.
So it's the opposite, which is root 11/6. Y squared is 11 without the root, but y is with the root. Mhm. Right, so that's how you would tackle that question. Right, any questions to do with that one at the moment? Everyone fine? All right. Okay, super. So this next one is a typical reduction formulae question. It says simplify to a single trig ratio. All right, so definitely we need to sort these angles out. Okay, they can't be these compound angles. They need to be reduced. So we always say, where is that? Where is 180 minus x? It's in the second quadrant. Sine in the second is positive sine x. Where is minus x? In the fourth. What is cos in the fourth? Positive cos x plus. Where is 90? 90 plus is there. What is cos there? Negative. Because it's 90, co-ratio of cos is sine x. Where is x minus 180? We swap it around and we say minus 180 plus x. So minus 180 plus x. Remember, negative direction is clockwise. Positive direction is anti-clockwise. So it's negative 180 plus x. In the third quadrant, cos in the third quadrant is negative cos x. Right, a minus times a minus is a plus. Sine cos plus sine cos is 2 sine cos, which is the double angle formula for sine. You can't leave it like that. They said a single trig ratio. Right, so it's important that you know how to get into the correct quadrants so that you know if it's positive or negative, and then reduce accordingly. If there's a 90 plus or plus or minus 90 plus or minus x, it is co-ratio. Co-ratio of cos is sine. Okay. All right, any questions over there? Nothing? All right, so 5.3. Sine 3x cos y plus cos 3x sine y. Right, you want to find the value of that given that. Okay, all right, but when you look at this, you should immediately recognize that sine cos cos sine is the compound angle formula for sine. And plus means plus. And it's 3x plus y. And there is the 3x plus y. It is 270. So it's the sine of 270. And the sine of 270 is negative 1. You can use your calculator for that if you don't know it off by heart. So it's important to recognize the compound angle formulae in reverse as well. All right, and then 5.4. I'm going to clear this. 5.4, they give you this, and they want you to show that it can be written like this. So in other words, the whole equation must be converted to sine. Right? Okay, so if we start with 2 cos x is equal to 3 tan x, the very first step is to check that the angles are the same. They are. And then you change everything to sine and cos. So 3 sine x over cos x. Equations with fractions, LCD, of cos x. That's missing a cos, so times by cos. That has a cos, so it's just 3 sine x. And then we're going to change cos squared, because we want sine squared, right? So we're going to change cos squared to 1 minus sine squared x. All right, so 2 minus 2, we're going to multiply out. I'm actually going to bring this over. And then rearrange it. And then we do not want a negative in front of that first quadratic. So we divide through by a negative. Right, and then we have a quadratic. So we need to factorize. All right, so this is 2 sine x, sine x. First times first must give me first. Then last times last is 2. So it's either 2 times 1 or 1 times 2. And it's going to be 1, 2. Because then you get sine and 4 sine. So plus, minus. All right, so if we put each of these factors equal to 0, we're going to get sine x equals a half, or sine x equals minus 2. Okay, now shift sine 2 gives you an error. This is a sine graph. It doesn't go up to more than 1 or down to less than minus 1. So this, there's no solution for. Sine is positive, first and second. Reference angle, arc sine half or shift sine a half. Sine of 30 degrees gives me a half. When I shift sine, I get rid of sine, so x equals 1 for each quadrant. First quadrant is the reference angle plus k 360, where k is an element of integers, z. And then second quadrant is always 180 minus the reference angle plus k 360. Remember, it's plus a whole lot of revolutions, which will take you back to the same place. And those two are my general solution. Okay, this part of the question is done over here. There, we've done it. That is correct. Then they say determine the general solution of this, which is now that. That is the general solution. So just have a careful look at that before we look at the rest. All right, so now I have my general solution. Now it says, hence determine the two values of y between those two values that are solutions of this. Now this looks very similar to the original, but x is 5y. Okay, so we know that x equals 5y. And if I'm trying to find y, y is x over 5. Right? Now, if I substituted in 0 here, I would get 30.
Yeah, I don't understand how you got that.
To got that?
Yes, ma'am.
Which that? Which set? Which line?
X 45y.
Here. They gave you that formula there that they've given you, that x is in the place of 5y. Otherwise, it's the same. 2 cos 3 tan, 2 cos 3 tan. So it's a similar expression, But in place of x, there's now a 5y. And then y will be x divided by 5. Get rid of the 5. So now if I have x values, I can sub them in and find y. Right, are you happy with that? That's correlation. Okay. All right, so x values, if I put in 0 here, I get 30. 30 divided by 5 is not between those two values, right? If I put in 0 here, I get 150. 150 over 5 is 30. It's also not there. Okay. If I put in 1, I get 30 plus 360, which is 390. 390 divided by 5. Can somebody just work that out for me? So 390 divided by 5. 72, I think. No, 78.
78.
Okay. So that's also not between those two values, is it? For y. So it's definitely not that. If I put in 2, 2 times 360 is 720 plus 30 is 750. What is 750 divided by 5? It would be 150, I think. 750 divided by 5. And that is between those two values. And then I could go and put in 3 if I wanted to, and divide by 5. So I want you to please go 3 times 360 on your calculator, and then add 30, and then divide by 5, and see if you get an answer between 144 and 216. I don't think so, but just check.
No, ma'am, you got 222.
Exactly. Okay, cool. So now we go, yeah, we put in 0, 150. 150 divided by 5 is 30. Definitely not, right? We put in 1. 150 and 360 is 510. What is 510 divided by 5? That I also don't think that works. It's 102, isn't it?
Yes, ma'am.
So it's not, right? Okay, so we put in 2. 2 times 360 is 720 plus 150, 870. What's 870 divided by 5?
174.
Go. And I'm quite sure if you put in 3, it won't work. You can double check. So this was your level 4 question. Okay. Okay, so this was a tricky one. Well, first of all, you had to recognize that there was a similarity between these two expressions and what equaled what in order to find, and they said find y, so you must make y the subject. And the only way you can find y is if you have x, so you needed to go and sub in k values. Remember, k is an element of integers. So it goes back to your general solution. All right, and then I just have a question here that somebody sent me, so I'm going to do it as well. All right, it is as follows. Determine the general solution of 4 cos squared beta minus sine beta cos beta equals 4. And it said general solution to 1 decimal place. Right. Okay. Okay, this doesn't look like such a nice one. But the only thing that we can do, everything is already sine and cos. The only thing we can do is change that to 1 minus sine squared and see what happens. right? Okay, so if we multiply out, remember you have to do what you can do. That was the only thing you could do. There was nothing else you could have done. Right, now do you see the 4's cancel? The 4 on each side. So you're only left with those two terms. And those two terms have a common factor. Okay, you can take out a minus sine beta. And if you take out a minus sine beta, you are left with 4 sine beta plus, because a minus times a plus is a minus, cos beta. So either sine beta is equal to 0 or 4 sine beta is equal to minus cos beta. Right. That is easy to solve. Right, sine is positive, invisible plus, first and second, reference angle, shift sign 0 is 0. So beta equals or beta equals. First quadrant is the reference angle, 0 plus K360, K an element of Z, or 180 minus 0, which is 180 plus K360. Those are your two general solutions, which actually you can write together. I'm going to show you how just now. And remember, when you have a sine equal to a cos, you can divide both sides by cos. So for tan beta is equal to minus 1. So tan of beta is equal to minus a quarter. Tan is negative there and there. The reference angle is arctan a quarter. Don't put in the minus. So please tell me what that angle will be.
Ma'am, should you put the minus a quarter or should you only put a quarter?
Only the quarter. The minus tells you where you're working. This is how I do it, okay? There are other ways. This is the logical way.
Ma'am, it's 14,0304.
Perfect. Okay? So beta will be second quadrant, which is 180 minus that. What's 180 minus that? 165.96, I think. And remember, when you're doing tan, you only need to do the one quadrant. You don't need to do the other. Why? Because they are 180 from each other. If you add 180 to that, you automatically get the other one. If you add 180 again, you get the next, then the next, then the next, then the next, in either direction. Right, so this is your one general solution. These are two, but they can actually be written as one, because K360 means I'm at 0 plus K360 plus any number of revolutions, so I'm there. Always going to be back there. 180 plus K360 will always take me back there. But do you see that if you add 180, 180, 180, 180, you'll always get the other one. So these two can be written as K180. If K is 0, it's there. If it's 1, it's there. 2, 3, 4, 5, 6, etc. That is a general solution. Beta equals that or that. Those are the two general solutions for this problem. Okay, so please remember, do what you can do. If you look at this, you can't look at that and go, I can't do anything. You've got to look at it and go, well, I can't do anything to 4. I can't do anything to sine beta cos beta. I mean, what's there to do? But cos squared has an identity. So use it and see what happens. Usually, if you do what you can do, it then all starts falling into place. Your problem went away. You ended up being able to take out a common factor. In other words, you could quite easily factorize them. And remember, once it's factorized, you just put each factor equal to 0 and solve. Like any normal equation, even in algebra, it's factorized, put each factor equal to 0. Obviously, these are trig functions, so if you're solving an equation with trig in it, you obviously need to know the process as well. Right. Okay, cool. So that was a question somebody requested. Yeah, okay, cool. I hope that helped. Please go and practice them again, okay? Go over these questions again. Remember, the recording gets made available, and then you can go over it again. Do it all by yourself first, and then you can look at the solution afterwards. It's the only way. You've actually got to do it, all right, on your own. Okay, super. All right. Okay, super, guys. I shall see you on Monday.
Thank you, ma'am. Bye. Have a good day.
Have fun. Work hard. Last stretch. Okay, bye.